Thanks everyone for joining me today and hear about Confluent's journey to Distroless and some of the pitfalls and the lessons we learned along the way. Hopefully I can save you some time in your own migration, or at least warn you of some of the things you're going to trip on. My name's Luke. I'm a principal security engineer at Confluent. I'll spare you a full about me slide. But at Confluent, I've been driving our migration to Distroless over the last few years, and specifically with Chainguard eventually. All right, so what we're going to talk about today, I'm going to come back to a couple key points. I'm going to talk about the value of meeting your developers where they are. So giving them a solution that works for them today. You don't need to immediately jump to your end state on day one. I want to talk about how visibility is crucial. It's funny, I didn't actually get any sneak preview of the keynote today and the talk about how important it is to know what images are running in your environment. Got quite a few slides on that. We'll talk about kind of where some of your visibility gaps are. I'm going to talk about the value of stopping the bleeding and the concept of this, basically when you're doing large-scale migrations. And then finally, we're going to talk about some common technical pitfalls. So you want to be aware of where these things are most likely to break during your migration and hopefully fix them, or at least let your developers become aware of them before you run into them. Awesome. So first, I want to give a real brief technical background about Confluent Cloud for folks that are unfamiliar with our company and products. Confluent Cloud's a unified data streaming platform built on the heritage of Apache Kafka and Apache Flink. Basically, we help our customers stream, process, and govern data at scale. But to accomplish that, we allow customers to create resources, like, say, a Kafka cluster, on demand. So typically, they want to create those clusters in the same region or the same cloud provider where they're already operating. And so what that means is that we end up having to run a very large multi-cloud environment across AWS, Azure, and GCP, and over 90 total regions in order to support those customer workloads. We also offer Confluent Cloud for Government, which is primarily hosted in AWS GovCloud, which brings with it all of the FedRAMP requirements, such as FIPS, but that's a talk for another day and maybe a few more drinks. To operate our services effectively at this scale, we make heavy use of Kubernetes. We have many thousands of Kubernetes clusters spread across, again, all of those clouds, all of those regions. And within those clusters, we run hundreds of Docker or OCI images, but primarily Golang or Java-based services. Now, we didn't start out with the end goal of migrating to Distroless. Instead, we started where I think a lot of companies start, a vulnerability management problem. I think many people in this room have had the experience of running a vulnerability scanner for the first time across all the images in your environment, and it spits out some terrifying number of CVEs, and it just seems unapproachable. We certainly had that experience as well. And so when we started to break down what all of those CVEs were, we found that the majority of the CVEs in our environment were actually coming from OS packages. So curl, bash, OpenSSL, not coming from third-party libraries that our developers had imported. And so seems like an easy thing to target first. We'll try to clean up some of these OS packages while we, in parallel, are trying to tackle the application dependency problem. Now that leads to a pretty obvious next question. What OS were we even using in our images? So before we could begin to address that, we had to figure that out. We sat down with our engineering teams. Turns out that was a really complicated question to answer. We had a couple different competing base OS images. So some people might refer to these as golden images, or kind of, these were actual images. We weren't just using straight up library/Ubuntu. We were maintaining an internal version that had, a couple additional packages added to it, maybe some certificates copied in certain places, our own modifications on top of it. And what we found is when a team needed a debugging tool to respond to an incident, they would just go and add it to the image. So every time they had an incident or an outage, they would go, hey, it would have been really convenient to have, Nmap installed in our image. They'd go add it to the image, and then next thing you know, Nmap's now part of every single service for the next couple months. So not ideal. The other thing, we had inconsistent or unclear ownership of some of those images, and so that led to the problems you'd expect, delays in updating of those packages, and similar. Now, this is where we made one of our first big decisions. We could have easily put out a mandate and said, this image, Alpine latest, this is the blessed image from InfoSec. You must migrate by the end of the quarter or else. But frankly, we didn't have enough information to make a decision on what should be the standard image at that point. We didn't understand how people were using it. We didn't understand how they were using some of the tools installed. Were they used only during incidents? Were they used during runtime, maybe? And that we needed that information. So instead, we decided to take ownership of all of the base images as the InfoSec team. So we said to each of these teams that was maintaining the base image, hey, we're going to take this over, and we're going to be responsible for patching it and keeping these utilities up to date. So we'll take it off of your hands, and what that gave is every developer had a blessed path forward to get to less CVEs. Definitely not zero, but less than what they had right now. And it allowed us to start to kind of get a handle on the problem and get more understanding on how are people using these images. So we could start to talk to them about, hey, maybe we don't need this tool in every image. Can we take this out of the base now and have come from more of a place of authority of owning that image? This comes back to that key takeaway that I'll hit on a couple times of meeting your developers where they are. This was a really popular approach with our developers because they didn't have to worry about potentially breaking changes of, hey, I'm switching distributions and now these files I expected are in a different place on here, or these utilities that used to work no longer work. So that worked out great in our favor. I think moving on to the next one here. Oh, there we go. Froze up. There we go. Maybe? All right. So what did we learn from owning all of these images? As the expression goes, there's nothing more permanent than a temporary solution. So our plan to temporarily own these base images for a few months quickly turned into probably a year or more. But we had some really good learnings in that year. And so what we were doing in that time was basically keeping up to date with new versions that were released on Docker Hub of those images. And then also, when CVEs were found that weren't yet patched in the image on Docker Hub, we were adding that into our build. So basically, apt-get update, apt-get install, newer version of this package. And turns out that's the easy part. Keeping up to date, turn on Dependabot, or whatever your favorite version bumping tool, merge the upgrades. The real challenge comes from getting those new versions of those golden images out to all of your services and actually merged and then subsequently deployed to your production environment. Next, we discovered, like I said, there's legitimate business needs for many of the installed packages and files. Frankly, the first time I looked at the list of apt install, 20 lines of different tools, I thought it was ridiculous. And then we got to talking to service owners, and we found there were legitimate needs for many of these tools. They weren't just added arbitrarily, like your gut feeling might jump to as a security person. Doesn't mean we can't take them away still, and we can't find better options, and that's something we'll talk about in a little bit. Stability is a major concern. I know this seems obvious, but while we're shortly after taking ownership of some of these, some of our developers got bit by some of the issues with Alpine and Mussel and DNS resolution. It's been a few years since then. Hopefully you guys haven't had any issues related to that, but that really frustrated our developers. They want an image that just works and that they don't have to think about and pay attention to what changes are happening upstream that potentially broke their image unrelated to their code. And finally, as we started building out dashboards and tooling to track if teams are staying up to date with our images, we started to learn that we didn't have the visibility that we thought we did. So to explain what I mean by that better, consider a simple case where you've published a new version of your base image and you want to know what teams in your environment have updated to that new base image. The problem here is that the vast majority of deployment and orchestration systems describe the desired state. So you create a deployment or a daemon set, and you describe, I want to be running version whatever of this image. That doesn't necessarily reflect the reality of what actually is running. So you might have configured, say, rolling upgrades, and so it's only going to progress through one pod at a time, or it's going to wait for a pod to come up healthy before it moves on to the next one. What if that pod never came up healthy? Now you've got a partially rolled upgrade. What you're still running in your environment is that older version of that image. And this is true of other things too. If you think about even Terraform, for example. When you perform a Terraform plan and a Terraform apply, then that state is great at the end of that apply, but it can drift over time. Maybe someone went into the console and modified a resource, or maybe some automation did because it rolled back an upgrade. So you go look at the Terraform and you think, hey, we've got this version rolled out everywhere. Turns out that's not actually true. So my key takeaway from this is basically for any sufficiently complex system, the only thing you should be observing is the actual state of the world, as close to the source of truth as possible. So for Kubernetes, this means observing the state of the pods across all of your clusters, not their parent resources, like deployments or replica sets, daemon sets. If possible, you might even consider going a level deeper, monitor the running images according to containerd or your underlying container runtime. There are still footguns in Kubernetes where you can delete a pod and it's still actually running on the host if you're not careful. So now, you probably think that you have this visibility already in your environment. You might have some level of monitoring system in your environment, and you go, oh, I can go take a look at the metrics that are emitted, what pods are running, what image tag was running on them. But I bet money that you're actually missing visibility there and you don't realize it. So one key example is an init container. So in a Kubernetes pod, you could say, I want to run these containers at the start of the pod. They're going to do something once, and then the container is going to run and be long-lived doing whatever it does. If that's no longer a running image, your metric system probably isn't emitting any metrics related to it. And so you might think, hey, the main application image is upgraded, we're running the latest version, everything's wonderful. But in reality, every single time that pod restarts, that init container is still running old, vulnerable code in your environment. Another example would be cron jobs. I've got a cron job that only runs for 10 seconds once a month. Does your metric system pick that up currently? It probably does, but you might need to change how you're querying it in order to get that visibility. We ended up building a custom solution for this that basically gave us an aggregated kubectl Git across all of our thousands of clusters. That's been wonderful for us. It's been useful for a bunch of other purposes. But either way, I would strongly recommend you partner with your Kubernetes team if you've got one, your observability team, and your cost team. They're a wonderful partner because they want this visibility too. They want to know what workloads are running in your environment, how much CPU and memory they're taking, and subsequently how much they're costing the company. And so they're great partners to try to learn more about kind of what's running. To take this another step further, where you lack visibility, you probably don't have the visibility that you think you do in your version control system or your build system either. Let's say you wanted to say how many people have upgraded to the new version of your image. You could say, hey, we've got Dependabot, it bumps the image. How many people have merged the Dependabot PR? And that's a good approximation. It's a great place to start. It's probably not accurate. You might have a team that went and upgraded the version manually, just on their own, because they didn't realize that Dependabot had opened a PR for them. Or maybe a new service was created, and it's using the new version of your image already from day one. Is that appropriately captured in your metric of how many services have migrated, how many are on the new version? Kind of the same solution here, though. You want to be observing the actual state of the world. You want to be looking at what's on the master branch or main branch of your GitHub repo. Or even better, what's actually being produced into your image registry. So what is the build finally producing, and what did that use as its base image? If there's one key takeaway I could mention here that'll save you a bunch of headaches, go look up the Open Containers annotation spec and go put it in all of your builds today. Even if you're not changing the base image, even if you're not doing anything else, this will help you down the line. So these are basically a set of standard labels that you could put in that say like, hey, this image was built from this Git tag, or this Git revision, this Git repository. It was built in this CI job. Here's a link to GitHub Actions or to whatever your CI solution is. And the benefit of this is when you are later looking at what images are running in your environment, you can very easily correlate back, hey, this came from this Git commit or this build, and this is where I need to go make a change to migrate them to use a Chainguard image. In fact, some vulnerability scanners will automatically surface these labels as part of their results of an image scan. So you get it right there, the correlation of here's my vulnerable image, here's where I need to go patch it. All right, back to the journey to Distroless. So you've got all the visibility in the world. What's next? Next we have to figure out what we're going to move to. We've got all this visibility. We've been owning these images for a while. We got to select a solution. So obviously, we landed on Chainguard in the end. But there were a couple different reasons that we chose Chainguard. So 0 CVs, obviously that's the headline. That's a great plus. One of the big ones was the use of glibc versus Musel. So again, we had been bit by some of those stability issues, and just the fact that they had standardized on a reasonable baseline was great. Reasonable package management tools. So if you look at something like Google Distroless, it doesn't have a built-in package manager. So in those cases where you do need to break glass and I need to install Vim in production so I can go edit this file and break fix for whatever reason, you kind of want those tools available, or at least have a path to that. Again, ideally, you're not having those in your images. You're getting to that truly minimal distroless, but you don't need to jump to that end state on day one. One of the big reasons actually was the build tooling itself. So there was a talk earlier today talking about the Chainguard factory and a mention of kind of Wolfie. An interesting bit is that we actually first adopted the Wolfie images and the Wolfie build tooling. So we deep dived pretty hard into some of the work that Chainguard's doing in the open source community. And we took a look at those tools and we thought they were really strong tools from a technical standpoint. They were making the right decisions about how to check out code, do it securely, how to build things. It looked like it was going to be very easy for them to maintain. Easy is a relative term, of course. Maintain patching using this tooling. And so that eventually actually gave us the confidence to move to Chainguard. We thought they were making the right technical decisions. And then, of course, the big one is compliance. FIPS was a big driver for us in our FedRAMP environment. And having images from Chainguard that just worked, that you drop in, was a big plus. Got to take one quick detour. There's a lot of text on this slide. There was a much prettier graphic in the keynote that I wish I could have stolen about this, about the two different types of images and container images that you kind of have in your environment. You have first-party images, so this is the stuff you're building in-house, your software, probably built with like a Docker file. You migrate these to Chainguard's base images, is what they call them. And then you have third-party or application images. So this is stuff that's published directly, as it says, by a third party on a registry like registry.k8s.io or Docker Hub. And this is commonly open source projects, components. It might be vendor images, depending on what you're running in your environment. We're not going to talk too much about the application images side of this. This talk is mostly about the pitfalls and things you got to worry about on the left side. And that's because you don't really have to worry about much on those third-party images. They kind of do what they say on the tin. You drop them in, and they just work. That was largely our experience with third-party images, including the FIPS builds of stuff from Chainguard. If they have it in the catalog, it just kind of dropped in and worked. Maybe pay attention to what user it's running as or other things. But all right. Another quick note here. So one of the first pitfalls that we ran into and was very confusing for our developers was image tags. So if you're familiar with the Docker image, you probably are familiar like, hey, I pull Ubuntu:/latest. That tag is a human-friendly tag, and it points to an immutable digest. So it points to the version of that today. But tomorrow, that can change. It can point to a different digest. And seems obvious, I know. This is how they keep up to date with when you pull the latest version of a tag. It points somewhere. It's kind of like a symlink if you're familiar with file systems. Your developers may or may not be familiar with this concept and the idea that an image can change if you're just pointing to by tag. The most secure way to do this is to pin the digest, this long string here, in addition to the tag, and that way you get a 100% reproducible build. Now, Chainguard does something kind of interesting with their images and inside of their registry where these tags are mutable. So, for example, if I want to pull Golang 1.24, I can use the tag 1.24. And that's always going to point to the latest version of 1.24 that Chainguard is building, which is super convenient in your dev environment or maybe even your build system. Like, I don't actually care which minor version of 1.24 I'm running. You probably don't want to do that in your prod environment. You want something reproducible. But this is kind of confusing for developers too. In our case, we mirrored the Chainguard images into our registry, where we enforce immutable tags, where you publish a version once, it can never change again. We don't have a latest tag or something similar. And so our developers started trying to adopt Chainguard images, and the tags were mutating underneath them, and they didn't expect that. So there's a feature from Chainguard that you can opt into called unique tags, where basically they stop doing that. They add a little date string to the end. Again, the most secure way to do this is to pin a digest, but we're talking about on the human engineer level, it's more comprehensible to me that I have this string, it doesn't change. That's what our developers were used to. So again, we chose to meet them where they were rather than trying to change that view. Obviously, enough other people have that problem that they introduced it as a feature, so can't just be us. All right, next step, migration pull requests. So we chose Chainguard, we've fixed our tags, now we gotta actually move all of our services. Couple recommendations for this. I would suggest doing this centrally, actually. Depending on your org, centrally might mean something different. You might have a champion inside of each business unit or something similar, but it's a really good learning opportunity to figure out what build systems each of your teams are using, understand what their problems are, figure out that, hey, the build failed. Maybe we have a, in our case, we wrote a migration guide. I think Chainguard has some great ones now that they can help you through while onboarding. But, we try to run through that migration guide. Oh, something broke. Well, we need to update the migration guide. So doing this centrally gave us that feedback early on without having to go bug the individual teams and wait for them to give us feedback in that kind of slower cycle. Even if you can't get it to a passing build, this is still really useful. It provides a starting point for that service owner to take over that pull request and finish the work, and it's kind of a sign of good faith. You're making an effort for them. In the end, more than half of our migration PRs were done centrally, and then the other half were done by service owners following kind of the migration guides that we had written based off of what their service did. All right. I mentioned earlier the concept of stopping the bleeding. This comes from the medical field where someone comes in, something's wrong. Your first priority is stop the bleeding before we figure out what's wrong with them. Stop letting the situation get worse. And this is super useful in a lot of migrations, not just to Chainguard. I think it's a great strategy. You can start with, on day one, building your preventative controls and your enforcement early. So you build your, admission controller in Kubernetes or harbor policy that prevents images from being published that aren't distroless, and then you add an exception for all of your existing images. So anyone that's already got a service, you're exempt, your stuff continues to work, but if a team comes along and creates a new service tomorrow, they get blocked. They say, hey, you're making a non-distroless image, you're running a non-distroless image, don't do that, here's what we would recommend instead. And the reason that this is great early on is it quite literally stops the bleeding. It gives you a chance to prevent the problem from getting worse over time. Depending on how quickly your organization is growing, that might get you half your migration right there if you wait a year, depending on how many new services are coming along. But the other reason is these new teams are really great partners. They're early in their development process, so they're receptive to trying something new and seeing if it works. They don't have a whole bunch of technical debt or bad practices or patterns that they've accumulated over the last 5 years that you have to work through. They just have a brand new service that hopefully is following whatever your organization's baseline is. And because they aren't live yet, there's less pressure to unblock them immediately, right? Now, if they run into an issue, right, maybe something you didn't anticipate, whatever, add them to the exception list too. That's totally fine. It's just a good gate early on. And then it also gets you kind of your burn down list of over time, as you complete the migration, you keep shortening that exception list till you're down to just a small number. So how do you actually do that? I've got a couple examples here. You want to block running any images from untrusted registries. So this is typically done via a Kubernetes validating admission controller. Depending on your registry, what your registry you're using, you might have the ability to do sort of dynamic admission, where you're preventing new images from being pushed to it if they don't meet certain criteria. And so you could do a check there. Maybe you could do it earlier on in your CI or your build system. You add a check and say, hey, this build produced a non-distroless image. Don't do that, please. Or don't do that, we won't let this PR be merged on the more aggressive side. And then your kind of most complex option is actually blocking running non-distroless images in Kubernetes. This requires some custom work. So to give some examples of each of these, here's an OPA gatekeeper policy. So that basically blocks you from creating any container in Kubernetes that isn't running from cgr.dev. Now, you probably can't go roll this out in your environment tomorrow. You're going to break a bunch of stuff. So again, you need an exception list, and you need to work on those things. But this is a technical control where you'd say you can't run an image straight from Docker Hub. You can only run Chainguard images. On newer versions of Kubernetes, since 1.30, there's what's called a validating admission policy, which is cell language instead of Rego. You can do the exact same thing as what was on that last slide, natively in Kubernetes. You could say, hey, none of these images are running from the right registry. We're not going to permit them to start. And then here's the kind of the custom validation logic option if you want to, at runtime, prevent someone from running images that aren't Chainguard or Distroless. So in this example, I grabbed an image from Elastic, actually, who happens to be a Chainguard customer. And you can see the labels on their image here have, again, org open containers, image vendor is Chainguard. You can build into your admission controller to look up the labels on each of the images and check for the presence of this label or a similar one. Now, this can be spoofed. This isn't a cryptographically signed value, but if you have teams that are actively trying to circumvent your processes in that way, that's kind of a different problem. But yeah, you could build this. Now, one place, it's a lot of work to build a custom admission controller for this. That's kind of the path we took. But you could probably hook into some of your vulnerability scanners. If you have vulnerability scanners that run in Kubernetes, they're a great place to hook in because they are also pulling the image already in each of your pods and doing a vuln scan on them, including having access to labels. So you might be able to hook in to a place in there to do that. Like I said, can't be trusted. They're not cryptographically signed. There's a fun talk you should watch if you're curious about messing with the scan results and other things in that field. But all right, talking about automating pull requests, circling back to that. You've got a couple different tooling options. You've got Digest-a-Bot from Chainguard, Depend-a-Bot built into GitHub, Renovate-Bot. My key feedback here on these is you want to provide as much context in your upgrade PRs. So we're not talking about the migration PRs. You do your migration once, give them maybe a link to your guide, tell them what's going to happen. When I'm talking about the upgrades to newer versions, you want to give them as much context as possible. What CVs were resolved in that new version? What changes in packages maybe? What other changes in the image potentially happened? And if you have robust testing infrastructure, you could consider auto-merging those version upgrades. Be careful, but if that's a good fit for your org, you can look into that. So to give an example of what that looks like, just to note on Renovate, we're working to upstream some of our work we did internally to understand the Chainguard versioning into the core Renovate bot product. That's only if you have unique tags turned on. Hopefully that'll get merged upstream soon. But here's an early kind of rough draft of one of the upgrade PRs. So we're adding additional context to this simple Python version upgrade. It's going from 3.12.3 to 3.12.3. What does that mean to me as a developer? Well, it means it patched this specific CVE, and it updated, clearly, glibc. Now, this is a bit verbose. We've cleaned this up a little bit. But this was super useful for our developers. They wanted to know, what am I merging? What is this change here? What is the potential impact, especially if something does go wrong? All right. Talking a bit more on technical pitfalls real quick, and then we'll wrap up. These are all going to come back to the same underlying problem here about running as root. Docker has this wonderful default of the default user in a container is root. It's not great from a security standpoint. You do get some levels of isolation still from using a container, but it's not a best practice. I'm sure if you've run CIS benchmarks or anything similar, this is one of the things you have to look for, is containers that run as root. But realistically, if you haven't done any other work around this, around CIS benchmarks or anything else in your environment, your containers probably do run as root. That's the default if you do, from Alpine, even from scratch. The empty Docker image, that's going to run as root by default. Chainguard images have a secure default. They run as a user quite literally called non-root. And it doesn't have full permissions in the image, as you would expect. But this is potentially going to break some things when you move your internal services over. So ways to fix this. One of them, this is kind of the best way because there's actually multiple ways you can get to running as root. It's a little hard to match with strings. It can be root, it can be 0, it can be an empty string. All of those will result in the container running as root. Kubernetes added this feature in the security context of your pod, run as non-root, and if you set it to true, it will refuse to run your image if your image is running as root. So you could work on enforcing this across your environment, maybe with the validating admission controller or a gatekeeper policy or similar. You're also potentially going to have other permissions issues related to that. So maybe you're doing stuff in your Docker file that typically runs as root, installing additional packages. One, you probably shouldn't do this. It's not a reproducible build at that point. But realistically, some of your developers are probably doing stuff like this. You do have escape hatches. So in this case, this is essentially sudo. Escalate to root, run a command, drop back to non-root just during the build. Again, not recommended, but you want to give your developers, again, a path forward. You don't want to just tell them, you have to migrate, you have to make all these breaking changes. You can do it piecemeal. Here, you move over, you still do the bad things in your Docker file, we'll clean that up in the next phase. The other thing is, you might have files that need to be writable by your application at runtime. Again, the copy command has chown, it can copy files owned by that non-root user, and they'll be writable at runtime. Same problem, this time Kubernetes volume mounts. If you're doing mounting of volumes into your Kubernetes workloads, the UID that you're probably running as is 0, and it has permission to write to that volume mount, and it's wonderful. And now you're running as an unprivileged user, and you're going to have problems. Short answer, FS group is the solution to that. You just set that to the UID of the non-root user, typically 65532, and now you'll have, again, read and write access to that volume mount. But if you have them, these are the places where developers are going to get tripped up. And lastly, kind of the lack of debugging tools. There was a talk earlier today talking about some of the options for this, cdebug, similar. This is where we had a lot of back and forth with our developers. So if you move them to a Distroless image that has truly nothing in it, they don't even have a shell, what do I use to debug? The Kubernetes answer to this is ephemeral containers. They have some rough edges, is what I would say. cdebug makes some of those edges less rough. Depending on what internal tooling you have, you might have better solutions available for that. But this is where you want to have conversations with your ops team or whoever's running your containers about, hey, do you actually need to get debug access in these containers frequently? What can we do to get you away from that pattern? Or maybe in the short term, we'll run a version of the image with bash in it, with a few utilities. Because again, small progress over needing to go all the way there. You get them onto a Distroless image. Maybe it's a little bloated, but it's not as bloated as what they were running before. All right, I'm over time. So in summary, here's where we're at today. 96% of eligible services are using a Distroless image. The long tail, like all migrations, continues. The places where we care about have migrated the most. So yeah, it's great. We're very happy. And to reiterate on those key takeaways, you want to meet your developers where they are, give them a solution that works for them today. You can continue to iterate. Visibility is crucial. You probably don't have the visibility that you think you do in your environment. I would encourage you to spend some time thinking about all the different ways an image can become running in your environment. We didn't even talk about stuff outside of Kubernetes. You got Lambdas or Cloud Run or all these other places you want to consider. The value of stopping the bleeding. You want to prevent new violations from being introduced. And that allows you to meet teams who are early in their development process and change their direction. And then some of the common technical pitfalls, kind of all deriving from generally that same problem of running as root and then the lack of debugging tools. So you want to be aware of those, get in front of them, give your developers a solution. And that's it. I think we have questions. We can take questions. Yes, there's a mic.
All right, so you said 96% of eligible services. Where do you draw the line? What wasn't eligible?
I wondered if anyone would pick up on that. Yeah, that's a great question. So in our case, we use some of the managed Kubernetes offerings from the cloud providers. So EKS, AKS, GKE. They run images in your cluster outside of your control. So they inject, maybe it's kube proxy, maybe it's something else. We consider those services, we track them. We want to know if there's CVEs in those images, but they're not within our control. The most we could do is file a support ticket and ask AWS to patch those. So I would consider those a ineligible service. We've put in requests to them and asked them to move to Distroless images, but they might not. The other example is vendor images, where a vendor, maybe you're running the Wiz scanner. Now, I think Wiz is a Chainguard customer, but if you're running a vendor image, you might not have control over whether or not that can move to Distroless. The most you could do is drop in a feature request for them.
First-party apps, or first-party services, which you couldn't move to Distroless.
I don't think so off the top of my head. Our definition of eligible, though, did change over time. So what we actually started with was the low-hanging fruit. All of the Go services were the easiest ones for us to move. And so we started with just, if you're on Go, you're eligible to migrate, and worked on them. And then eventually expanded that scope larger and larger to include Python and Java and similar. But nothing comes to mind as unable to migrate in the end. Maybe there's something in that 4% that I'm missing.
How was your experience with moving the third-party apps, especially given that you can't always kind of pull a Docker image, you need to consume a Kubernetes manifest or a Helm chart that further points to a Docker image. What was your experience and how did you move that over to Chainguard?
Yeah, it's a great question. So it was good. Like I said, the Chainguard images generally were truly drop-in. One of the only places where we kind of saw pitfalls there actually comes back to the same running as root. If the upstream image was running as root in their Helm chart, they might have the user ID hard-coded as 0, or maybe even as a user ID that doesn't match the Chainguard one. And so something, I think Chainguard calls out some of these in the image compatibility section these days. So something to be aware of there. Upstream Helm charts, most of them already allow you to change the image that's running because lots of people run their own internal registries. And so we didn't have too many problems where we were unable to change them. We did have a few where I think we either made upstream changes to the Helm chart to make them more flexible, just giving more configuration in the values. One example that comes to mind is tags. If for whatever reason there were a few Helm charts that took one tag version and not a per image tag, and if we wanted to run different versions of different images, that wasn't available in the values, and so we had to make an upstream change there. Yeah. I think there's one over on the left here. I don't know who has the mic.
I wanted to go back to what you were saying earlier in your talk, where you're talking about observe the reality versus try to anticipate. And I'm wondering, in the Kubernetes world, one of the things that we try to lean into is around declarative systems, where kind of self-healing or more anticipatory of detecting those lack of correctness in the final deployment. Is that something that you have found actually useful, or in the end, it still wasn't sort of sufficient?
Useful, yes. I would say still not sufficient. It also depends on the number of entry points you have into that system, right? So if all of your services all deploy with the same deployment system, you're using Helm everywhere, then you generally have that. You could keep on top of those. But if you have multiple entry points, you have the cloud providers managing some of the images here. Maybe you've got a chart that the vendor is installing via Terraform in this cluster, and you've got maybe owned by another team that's just installing stuff manually because it's a dev environment. Having all those different sources, it just became easiest to, again, observe the actual reality and then work backwards from that, of there's something bad here, there's an image that's vulnerable, or there's an image that's not distroless, how did it get here? And that's when you work backwards through those different layers, through the deployment up to what produced this, how did it get installed in the cluster.
So it's basically the same as the previous topic, which is 90%, 96% of available.
Yeah, exactly. The long tail is what gets you.
Thanks.
In the beginning, you mentioned that one of the challenges for developers is stability. And I think in my experience, like one of the main things that developers are worried with is like some random, one of their open source dependencies just make a change that is not backwards compatible, and they don't want to spend the time now to fix it and deal with that upgrade. Did you have any cases like this, and how do you deal with that?
Yeah, we definitely ran into it. It's hard. You know, it's understandable. They've probably been bitten before. Like, it's probably not an unfounded fear on their side. You know, that is the danger of running, you know, an open source project that you're not a core maintainer of. They might make a breaking change. What was helpful for us is kind of the stick of you need to be running a version, whether it's, you know, FedRAMP has strict SLAs on patching or your own internal SLAs. And so having the answer of like, hey, you need to solve the CV in the next, you know, 2 weeks, and your only path forward here is a newer version that Chainguard produced. You're going to have to do the upgrade, and if something breaks, you'll have to fix forward. I guess the only advice I could give is, you know, trying to encourage them to have robust testing environments and help them build that confidence so they're not just finding that out in production. But it is a challenge. That's especially when you first adopt and you might have to jump up multiple versions, or you're doing a lot of catch up until you stay with current and you're updating frequently. Awesome. I think that's everything. Any last questions? Otherwise, I think we're right at time.
Oh, let's give Luke another round of applause. Thanks, Luke.
Thank you.